The first session today, we're going to be showing a walkthrough of Ryder, which is our awesome IDE that supports Unreal Engine for game development. So Matt's going to be showing the IDE features in Ryder, including the AI assistant and all of its capabilities for Unreal game development. And then we'll switch over to me, where I'll show a walkthrough of TeamCity, building the project and its support for Unreal Engine build pipelines. So Matt, over to you.
Yeah, thanks, Daniel. So the whole idea of this really is to kind of show you a bit of the overview of the entire life cycle of working with Unreal. With JetBrains tools, we can do the whole lot for you, from editing and working with the code to then building your actual project as well and working with that. So I'm going to start with giving you a quick overview of Ryder and some of its really cool features then for working with Unreal. And as I say, we'll then hand over to Daniel. We can see on the screen now, I've got Ryder up and running. I've also got Unreal. Where are we? There it's in the background. Got the editor running just with a simple project. It's the Lyra game project there. We can see we've got it loaded up here. We can see we've got the project itself with all of its files, and then the engine loaded there as well. The first time Ryder opens your project, we'll index all of your files. So we'll go through and build an index so we can very quickly navigate around. And one of the key things we do here is that we actually index the engine in the background. So we'll make sure we prioritize your own files so you can start working with your files quickly. And then in the background, we will then start to index the engine. So you can carry on working with your own project while that's going on. One of the key things as well is that we've got this index, and it gives us a lot of power then to be able to navigate around the code, but we keep that index up to date incrementally. So if you make any changes, we only have to index just the files that change. We don't have to sort of re-index the whole thing. And so it's a much sort of lighter system once it's done that initial index. So the first thing we can do with that index that we built there is navigate around your code. And you can use the Shift keyboard shortcut to bring up our search everywhere. This is a really powerful way of understanding your code, finding things, navigating around, and walking around your code. And you can then just sort of start typing then to be able to find things. And you can see that the searching is very much about search everywhere. We can find everything. We can search for classes, files, symbols, and so on. And so if I just start typing camera mode there, you can see I've actually found a couple of files up front. I can find this C++ file and header file, but it's also find some symbols for me as well. So it's actually found me a camera mode field there, property, which I can then navigate to and quickly jump to. If I do Shift again, I can then quickly jump to a C++ file. Let's just close the Solution Explorer there. We don't need the Solution Explorer. We can search. It's much easier and quicker to jump around and search and find things there without having to scroll around and look in your Solution Explorer. One thing we can do here as well, we can just start typing, and we can start typing something like Inventory Manager, and you can see we can very quickly find things. But we don't have to type the whole name there as well. So if we got the Lyra Inventory Manager component, I can just type LIMC, and it can then very quickly find those things too. So it matches based on the capital letters in those words as well. And it's a very quick way of navigating around to be able to find the code that you're looking for without having to type the whole thing out, which is pretty cool. When you are using Search Everywhere, you can see we've got items across the top. We've got all classes, files, symbols, and so on. And this is our way of being able to narrow down the search. So I can actually just hit Tab, and it can go off and it can find and search classes for me. Or I can hit Tab again, and it'll go and search files. And so it'll just go and find me things matching file names. Or I can go and search just for symbols as well. So I can then very quickly go and find a method. If I'm looking for a specific method, I can easily, such as the listen to input method change, I can very quickly go and find that. You can see we've also got a couple of other tabs here as well. We've got actions and we've got text. If you want to just search for text, we've got two different ways of doing this. We've got a quick search here for being able to find like a very specific bit there. We've also got a find in files function as well for doing that. So you can also search for text. One thing we've got which is really useful is to be able to search for actions as well. So LIMC is not particularly useful there. If you can't remember where a particular feature of the IDE lives, you don't have to go searching through all the different menus for it. You can just search, use search everywhere, use the find actions tab, and then just go and find it. So let's say we wanted to rename something. And if I can't remember what the keyboard shortcut is to rename, I can just find it in my actions there, and it'll show me the item. I can invoke that. It'll also show me the keyboard shortcut there as well. If I wanted to add a bookmark, so let's say I'm at this line here, this check method, and I wanted to add a bookmark so I can quickly jump back to this point at a later date. If I can't remember what the keyboard shortcuts are for bookmarks, I can just start typing here. I can use my actions tab there, and I've got a whole bunch of different options for adding and working with bookmarks. I can view the bookmark tool window. I can toggle specific bookmarks there, or I can just use the first item here, which is going to give me my menu from which I can do a whole bunch of things to do with bookmarks. So finding actions is a really useful thing we can do. If we just hover over the Actions tab there, we also see it's got a dedicated keyboard shortcut. So I can just very quickly jump straight to Actions there. And it's a great way of being able to find how to do things in the IDE if you can't remember a keyboard shortcut and so on. So we've got a nice way of sort of being able to navigate around with our shift and our searching. When we're actually there, there's other things we can do as well. The main keyboard shortcut we've got inside the editor itself is Alt and Enter. So Alt Enter brings up a little context menu of all the actions you can do at this particular point of code. So for example here, we've got options to convert to a trailing return type, change the signature. We can add some documentation to it and so on. Down the bottom of this menu are some items which are almost always here. So this is a great way of kind of, again, being able to find your way around the IDE, find out all the functionality that we've got available. If I go to like an empty page, for example, sorry, an empty line, then I hit Alt-Enter there. There's no sort of context items I can do here specifically, but I get options for these entry points into functionality. So I can navigate, I can refactor, I've got inspection items there, and I can generate code. And there's also some AI actions as well. We'll talk about AI in a little bit. Let's just go to, in fact, let's go to the class for camera mode stack. There we go. So we've got our definition for class. Obviously, Control-click will navigate you to somewhere very easily too. If I hit Alt-Enter here, and I can have a look at things like the navigate to, we've got a whole load of very smart, rich navigation functionality built in here as well. We can do really interesting things like go and find the base symbols, and that will take me to UObject, and I could do that again, navigate to base symbol. If I wanted to do that more frequently, I don't have to go through the different menus. It's telling me there I can just use Command U to go up the class hierarchy, but I can then sort of very quickly navigate around. I can use my navigate to menu again and go to derived symbols. And probably let's go to something a little more simple with that one, because there's going to be a lot of objects derived from that. UObject is also going to have plenty as well. Let's go find something a little bit more useful. Camera mode, everything's going to be from UObject. Well, let's see if there are anything derived from camera mode. Derived symbols, as it happens, there are. This is great. So I can go and see the derived symbols as well. So I can walk up and down the class hierarchy nice and easily. I can also actually show it as a diagram as well. So let's try that. And I can bring things on there. I can right-click, add on reference types, and build up my type diagram with that too. So there's a lot of different sort of entry points we've got for navigation. So again, we can do navigate to. We can do other useful things here, but the one which is perhaps the most useful here is going to be find usages. This is a really useful feature because I've got this class here, my camera mode. It's really nice to understand what it's doing, but I probably actually want to go and see how it's being used there. So I can use find usages, and Ryder will very quickly show me all the different places it's being used there. This little window here is really helpful as well. It shows us grouped up, the results all grouped. I can see I've got one usage in plugins. There's more things going on in the sort of source folder, and I can then sort of very quickly navigate around and see what's going on there. There's a very useful item on the toolbar here, this group by usage type, which is really nice when you turn that on, because it not only kind of groups by location of the result, but also by how that is being used there. So for example, here we can see it's being used as a base type, or it's being used as a function return type. And that's really useful because you want to know how you can get a particular instance of something. And there we go. Now I've got an easy way of understanding where I can get an instance of this type. You can also see where it's being used as a variable declaration, nested symbol definition, other things, template arguments, and so on. Also shows you things like new instance creation as well. So find usages is really helpful. You'll notice as well there's a preview window on the side here, and this is actually just another editor, so you can actually start typing here as well and edit the files even in the preview. Let's go and see, in fact, let's go to here. One of the other nice features we can do here is go to all the members of the file as well. And so I can see all of the items that are in this particular file here, and then I can just start typing to navigate around. And if I go to, let's actually go to the method here. If I've got this blend function here, what I want to be able to do here is use my inspect this menu item and have a look at the incoming calls. This is a really useful feature because find usages tells me where something is being used. And if I then see, well, okay, I can see where that's being used, but where is that thing being used itself? And I want to sort of continuously ask that question, then this incoming calls can answer that for me. So I've got my blend function here, and I was like, well, who's calling this? And I can see that blend stack is calling that. And then I can click there and navigate around and see blend stack. And it's like, well, who's calling blend stack? And I can continually expand this call stack to find out how everything is being used. And then you can see then get a better understanding of what your code is doing, how it's being used, how it's being called, and the flow of the control flow of your program, which can be very useful. So that's some of the navigation features we've got, which is very helpful inside Ryder. Obviously, we do a whole load of things with editing as well. So for example, if you want to add a new class, you don't have to go to the Unreal editor and add it through there. You can actually just edit directly in the IDE itself. So if you right-click on a folder or a project inside your solution view there, you've got the add menu there. I can just add a new class or a struct, and it'll fill that in for me there, and it'll create it. Am I in the right place? Yeah, let's try that one again. Or I can go down the bottom here, and I can do add a new Unreal class or an Unreal test class as well. If I want to add a new Unreal class, I get a whole bunch of options there. I can give it a name. I can derive from one of many parent classes there. We give you some common items here, or we can then go and see all of the classes, and then I can sort of start to search for things there. So let's just search for character, and it'll very quickly find things. I can declare it to sit in the base folder, public folder, or put everything both in the private. So it's a great way of being able to quickly create your classes and work with your code without having to go through the Unreal editor itself. There's also some nice features for editing. Let's just get rid of that one. So for example, and let's close that. When you type, obviously we've got code completion there, and it's very quickly appears. You just start typing, will complete everything for you. We do a few things which are quite nice and smart as well, though. So obviously here I can use the arrow operator to do something. But if I can't remember whether it's the arrow operator, the dot operator, what's the method we're using there? Evaluate stack. So if I just do evaluate stack, then you can see that Ryder actually fixed that up for me. So I was using the dot operator instead of the arrow operator, Ryder knows that I've made that common mistake there, and it'll just fix it up for me, which is a really nice sort of convenient way of helping you and working with you while you're editing. We've got other nice features as well. If I go down towards the bottom of this, have we got? Oh, I haven't got a method there. Another nice features with the idea of code templates as well. So you can just start typing and we'll expand a whole lot of code for you. But one of the nice things we can do is postfix completion. And this is a really nice way of working where you can have a template which is evaluated at the end of an expression. So the idea of this one is to actually allow you to concentrate more on the data, on the API calls that you're doing, and then you can actually add the syntax automatically for you. And we can do lots of different things with that. So where are we there? Determine camera mode delegates dot is bounds. And then I can just do if again there, or I could do dot else or dot var to create a new variable, and it will fix up the code for me, and it'll just write all the things for me. So it's a very interesting way of changing how you work with things. Let's just roll that one back. Obviously, we've got integration with version control, and we can see what the differences are with your files and stuff, and I can quickly roll things back. We'll highlight items in the editor as you're working. Another useful thing for editing is the way that Ryder can automatically format your code. And one of the nice things we've got here is the ability to format slate calls as well. So we've got specific formatting for slate. So I got a bit of sort of DSL there. If I highlight this, use Alt-Enter, I've got my reformat and cleanup item, and I can just reformat the selection, and it'll rewrite that code, and it'll format it for me nicely into the sort of DSL that you expect from slate. We can do the same in this one. If I do Alt-Enter, reformat and cleanup, reformat selection, and you can see it's reformatted my code nicely. And you can see it's put all of these items onto different lines, but you can see with this one, they're still on the same lines. And one thing which is really useful is the ability to be able to configure this. So we can actually go to reformat and cleanup, again through Alt-Enter. And if we go to configure code styles, we actually get a dialog here which shows all of the code styles that are available for us to edit at this point. And there's a lot of different options we can have, but if we scroll down a little bit, we've got our slate formatting options here. And we can see that one of the items I've got is wrap slate chained calls. It says chop if long or multi-line. I can drop that down and I can say chop always. Let me just try and move this around a bit so we can see both things at the same time. So if I move that over there and highlight this again, Alt-Enter, configure, bring this over here, and down to the bottom here, chop if long or multi-line. If I do chop always, then it actually updates the text while I'm working with it there. So I can change my configuration and it'll actually show me what it looks like. And so I can very easily understand how I should be configuring my code to get the formatting that I want. And so if I just then save that, it's updated both my formatting styles and also the code itself. Another nice feature that we've got for editing as well, if I use Alt-Enter on my class name here as another widget, again, I've got my different options and different features that I can do. I've got my main entry points down the bottom here, such as navigation, inspection, and so on. I've also got refactorings as well. And there's a number of different refactorings we can do where we can automatically rewrite your code for you. I can change the signature, so I could add another parameter in here if I wanted to, like, if I could add in a string or an integer or something. And let's just come out of that because I want to do another one. Refactor this. We can do a safe delete to make sure that it's not being used by anybody. So if I wanted to delete a function, I can just make sure that I'm not going to introduce any compile time errors here because I can it's actually being used. Or more importantly, I can do a rename. This is perhaps the most useful refactoring that we've got. I can safely rename something which is going to be used across lots of different files without having to do find and replace, which can always be a little bit tricky. there. So I can just create S another widget. And in fact, the AI assistant has jumped in there with some suggestions, which is rather nice. It's suggesting I'm going to call it a game API widget, and I'm going to go with that one. And so if I rename that, it can update it. It wants me to update my source controls. Let's just add those. And one of the nice things that we've got on top of that is if I go, let's do an item like this one, which is a component. There we go. That's the thing I want to see. If we were doing something which is an Unreal class, then obviously this could be used inside a blueprint, and renaming that might break things. So what we can actually do is Ryder, when it recognizes that you're going to rename an Unreal class, it can add a core redirect entry. And if we go to our commit page here, let's just pull that down a little bit. And if I go into the config file, I can see that the default engine.ini has added a core redirect here from Lyra camera component to my renamed instance there. So now it's not going to break the code when I want to work with it. Let's just rename it back to make sure everything's okay. There we go. And you can see that will have updated a whole bunch of files, and everywhere it's being used will be using the new name. Let's go to our inventory component again. What was the manager component? That's the one. Because there are some useful things in here that Ryder allows us to do with things like inlay hints. So for example, we've got a print statement here. We can see what the name of the parameters are. We've got the format item going on there. We've also got some nice little indicators here, such as this little inlay hint here, which if I highlight over that, shows us that there's a user-defined conversion going on. So it kind of gives us a nice little bit of an indicator to show that there's more happening here than perhaps you would see just based on the text there. We're calling an inline operator to convert that. Another example here is we've got the indicator to show us we're passing by reference, which is, again, very, very useful and helpful. We can go and see a few other things. Let's go to the cheat manager. And we've got a few more items being shown here with the parameter names, which is useful. We've got things to show us when you're at the end of a namespace, which is good. And if I actually go, let's go to the header file there, because nope. 1 second. Nope, I've just lost where I was going to go to in my code. Let's jump to a different item here. So we've got input.cpp. Some of the settings, some of the inspections that I wanted to show you. So there are a number of things going on here whereby we can actually help with your code. And so we'll inspect your code, we'll look for common issues and things which we can help improve your code and work with things. And one of the things we'll do is we will look at your include files and see what is possibly unused. We can highlight those to say that you're not using any symbols from these include files. And again, we can do the Alt-Enter item there to be able to remove all of the unused items there. So Alt-Enter can help you rewrite your code to fix some common errors and mistakes. We've got a couple of other sort of features and useful things. So if we go to our a demo file here, we've got so we've got an inspection here which is being flagged up because what we actually do is we'll run Unreal header tool on your code as you type. So instead of having to wait until your code until you build your code, you compile your code, we can actually run it as you type there, and we can show you that there's an error here. So we've got a replicated function there, but we're actually using a return type. We're using a return type. We can't have that. So that we do other things with that. So something with blueprint assignable. It's not allowed on a multicast delegate type, delegate properties, and we'll obviously Unreal header type will flag this and show these as errors. and it'll show those immediately rather than having to wait until you compile, you're doing the next compile. We've got a similar kind of thing with support for reflection macros as well. So for example, here, if we've got a property, there it is. The Unreal header tool's kind of getting in the way there. But we've got code completion then for all of your macro specifiers here. And so we can show all the items that are available there, and we'll actually give documentation for it as well, just as a little hover documentation to help you work with your code and understand what's going on with the reflection macros. There are a couple of other items which we've got here. So for example, if you are using a uObject item without the uProperty macro there, then we'll warn you that this could actually get destroyed during garbage collection there. So you can actually see that you might get a stale pointer. We're going to help you out there, and that you need to have the uProperty macro available. Otherwise, you might encounter problems at runtime. Other sort of simple inspections, nice one there. If you've got a struct, for example, then but you've got it with annotated with the uClass macro, we can highlight that actually it's a struct and you're using it with a class, so that's going to be incorrect there. And we have other items misgoing as well. So for example, a class with a generated body macro there, it's missing the uClass declaration. So we can actually use Alt-Enter to then very quickly add that in and carry on working. There's a number of different inspections and quick fixes to work with macros and so on. Now, one of the nice things that we'll do is index all of your files when we open up the project, but it's not just your source files that we index, we'll also index all of your blueprints as well. So we can see here we've got the camera mode item here. We've got an indicator just above it there to say that it's actually being used inside a blueprint class there as well. And if we click on that, you get to see where it's being used, and we can then also click on that, and if Unreal Editor is running, then we'll actually bring the editor, open the editor for that blueprint for you. So this isn't just for working with classes as well. It also works with serialized data. So you can see here, for example, we've got field of view. It's being set to the value 70 inside this particular blueprint. And again, we could navigate to that and we'll bring up the editor and allow you to change that. If we go to another one here, blend time, for example, that's actually being changed in two different places. You can see what the values are. It's a great way of being able to understand how your code is being used inside serialized data. And so if we open up this editor here, let's search for blend time. Blend time is this one here. You can see 0.22. If we change that to 0.35, for example, and if we save that and switch back to Ryder, then you can see if we click on that, Ryder has already updated it. So it's, again, very quick at being able to incrementally keep this data up to date with how you're using your code and how your code is being used inside blueprints, which is really powerful. Last couple of things then to finish up is that we've got some great integration with the Unreal editor itself. So for example, at the top of Ryder, we've got a couple of items here. So I can put us into play mode, and let's see if that's going to work or it's going to cause trouble based on the text that I've been working on. So that's switching us into play mode, and we can pause and carry on. And we can also stop as well. So I'll get full control of how I want to work with Unreal Editor from the tool window there. We've got some options here as well. So you can change things like the number of players, the spawn mode, and so on and so forth. We've also got some useful tool windows to integrate with the editor as well. So if you want to see what Unreal Build Tool is doing, you can see what the log file is there. Obviously, if it's a file, we give you a link so you can very quickly open the file itself. And we've got another plugin as well, which allows us to bring in the Unreal Editor log into Ryder. And this is useful because it's kind of the information about the code. So let's show it where your code is. and we can recognize when you're using a class and a method there. And if we kind of click on that, we can very quickly sort of navigate around and take you to that code there. So it's really useful to be able to bring that log into Ryder so that it will work with the code and show you where the code is being used itself. Okay, so last couple of things then. Let's just quickly show you a few of the things about AI Assistant. So if we go to back to our camera mode, and if we go to the implementation of, let's see if get world is a good one. There we go, get pivot location. The AI assistant that we have got allows us to do a number of different things, and we've got a bunch of interesting actions that you can work with. We've got a chat, so you can ask it questions, or you can have some actions which are already built in, such as explain the code there. So if you've got a big method which is doing a lot of stuff, and you want to sort of get a quick summary of what's going on, you can then just ask the AI assistant to look for you. My machine's has that frozen? Having a few demo problems. Oh, okay. And my machine's woken up again. There it is. And so yeah, so we can ask it to explain some C++ code for us. It can see what's happening, and it can walk through that code and break it down to you and explain what's going on. And so it can explain code. It can you can ask it for things like, how do you do interpolation? How do you use specific APIs inside Unreal itself? And it will gather the context from the editor and display that and give you all the information that you need. And then so finally, as I say, we've got lots of integration with source control here. We've seen it here. We can, I'm using it with Git in this particular case. What you can do is show, have a look to see what the values are, what's changed, and then you can, when you're happy to work with that, you can stage items, you can type in a commit message, and you can then commit it. But one of the nice features we've got with AI Assistant is that it can generate the commit message for you, and that will then look at to see what the difference is between what has changed. It'll summarize that for you, and it'll generate a commit message and allow you to commit your code and push to the server. At which point, then I think we've now kind of shown everything shown a good introduction of what Ryder can do. There's a whole load more things we can do, but now we've committed code. I think we can probably bring Daniel in and show how we can use TeamCity then to build your code.
Yep, sounds good, Matt. Thanks for your demo. Yeah, Ryder's a really cool IDE. Thanks for that. Awesome. So I'm showing TeamCity here. I'm currently logged onto a TeamCity cloud server, and this has full support for working with Unreal projects. We also support Perforce. Matt was working with a Git-based version of the Lyra project, but I'm working on a Perforce version here in TeamCity. So if you're using Perforce, that's fully supported by TeamCity. So TeamCity is our CI/CD solution. It's a really mature solution, lots of features built in, and I'll show a few of those during the demo today. With TeamCity, if you have a Unreal project and you maybe are working with BuildGraph, we also have full support for working with BuildGraph. And if I go into one of my sample projects here, we can look at a build that finished earlier. I'm not going to show you a full working running build pipeline because it takes a long time to run. But if I switch to the dependencies tab here, we can see a visual representation of the whole build pipeline or build chain. So we're building the editor and cooking the game. So we're building for Windows and Linux. And on the configuration side of things, if I go to the configuration for this job, we can see that there is a dedicated option when you add a build step to choose Unreal Engine. So that's fully supported out of the box on TeamCity Cloud. And if I show you the configuration here, we have a Unreal build step, and I have chosen to run the BuildGraph command, and I'm pointing it to my BuildGraph script inside of my project and passing in a few different parameters like the client platforms I want to build for, the server platforms, and the target configurations. More importantly, though, I have selected the distributed mode, and what this allows you to do is when TeamCity passes your BuildGraph script, it's going to distribute all of the different jobs across all available build machines that you have connected to TeamCity. So you're not just running this build on a single build machine, you can run this on several build machines and split up the workload so you have a much quicker overall build time. So with BuildGraph, if I go to my IDE, we can see I've got the BuildGraph script open here. If you're not familiar with BuildGraph, what this essentially means is you can define all the different jobs in here. So all the different agent tags define all the different parts of the build pipeline. So we've got a node here for building the editor and the tools for a particular platform, and that platform is one of the options being passed in here. So what we're doing is we're passing all of these different agent tags inside of the XML file, and that gives us the dynamic build pipeline that we see on the screen here. So I've not needed to do any additional configuration for each of these jobs. This is fully automatically populated from our BuildGraph script. So taking a step back, let's first of all look at the Lyra project configuration. So in the project settings, we can see I can define various VCS routes, and we can see that Perforce is one of the supported options, as well as Git. So you can come in here, add your streams as needed. And for this particular job, if I go back in here and we look at the dependencies, as well as looking at the build pipeline view, we can switch to the list view and see all of the jobs that were executed in this particular run. We can see that there were some tests executed. I can click on here and then see the exact tests that were run, and you get the results, and you can also expand them if there's a failure, and you can see the reason why that particular test may have failed. We're also storing build artifacts on TeamCity. So if I hover over some of the artifact icons, you can see the like the Linux server zipped up here, as well as the Windows client associated with the job down here. So TeamCity retains all of the artifacts, as well as retaining all of the test results and build results. In terms of how these jobs are executed, we have the server here, which holds the whole configuration for the TeamCity project. But you then have one or more build agents, so build machines that are responsible for running those jobs. So if I switch over to the agent screen, we can see I've connected some self-hosted agents. So with TeamCity Cloud, we do provide cloud agents for you, but if you want to use Unreal Engine, you need to connect a self-hosted agent, which could be your own internal build machine. It could be an agent running on AWS EC2. It's completely up to you. And if you are using cloud agents, TeamCity can also automatically start and stop them, so you don't have those build machines running 24/7 and incurring more costs than needed. So I've got two build agents I'm using for the demo project today. I've got a Linux agent and a Windows agent. These are running on AWS. On the parameters screen, we can see all of the different parameters for the build agent. If I search for Unreal, we can see that there are some specific Unreal Engine parameters. So we've defined a shared directory so that all of the build agents are sharing this directory between them. So as we're building out the build pipeline, running the different jobs, all of the dependencies, all of the build results are being shared between the different agents. We've also defined a type here, and this determines which parts of the pipeline can be run on this particular agent. So I've assigned it the compile Linux, cook Linux, Linux types, and that means that all of the Linux jobs will run on this agent. So that determines where the build will be executed on. So this is using a shared FSX volume. That's how it's being configured. So one of the other cool features that's going to be released soon is we are working on UGS integration as well. So if I come into my UGS demo here, I'll show you what this looks like. And I have a kind of replica of my normal build pipeline, but I can actually run this now. It's been trimmed down, so it's just running some kind of sample commands. And I can run this. And because we've got UGS integration being released soon, this is a very early preview, I can switch over to my Windows machine here that has UGS running. And if I zoom in, you can see I've got all of my commits from Perforce listed here. I committed a file earlier, an update to the README file. And what we'll see is, if I scroll over to the right, the actual results, the badges will be populated by TeamCity as the build is running through. So we'll wait a few seconds for that to happen, and we can see the badges are starting to populate. So you've got the compile editor Linux, we've got the other jobs that are also waiting to run. So if I zoom out again, and you can actually click on one of those badges within Unreal Game Sync, and that will take you straight to that build over in TeamCity. So you have the direct linkage from UGS over to TeamCity. The status of all of the jobs is reflected in here as they're being executed. So the green badges are gradually populating in UGS as all of the different parts of the pipeline are executing. And let's look at how this is configured. So on the configuration, I can go to my Unreal build step. And down here, we've got the option to post badges. Like I said, this isn't in the current version of the release plugin, but it will be coming in the next month or two. But with this selected, you can then specify your metadata server. So TeamCity will push the statuses to the metadata server so that UGS can show them. If you're not using BuildGraph, though, one of the other options we support, if I go and add a brand new build step and I choose Unreal Engine, you can also define your commands manually. So rather than do BuildGraph, you can choose build, cook, run, and you can configure the build, cook, and run commands directly inside of the TeamCity UI. So for build, for example, you can expand this. You can choose the build configurations. You can also choose the target configurations, the target platforms. So we try and make this as straightforward as possible to configure your Unreal build pipeline inside of TeamCity. And if you prefer not to do all of this configuration inside of the user interface, you can also define all of this through code. And in TeamCity, we support Kotlin DSL, so configuration as code is done through Kotlin. And if I click the View as Code button, we can see a preview of what the equivalent configuration would look like. So we've got a command here for BuildGraph. We can see all of the different options and the parameters that have been set. So if you aren't using BuildGraph, you can still push the status of the build over to UGS. So there is a build feature called the commit status publisher. And if I choose the publisher as UGS metadata server, you can define your URL, the badge, and the project, and this will push the statuses for you to UGS. And if I switch back to my Windows machine, we can see that all of the badges are nearly populated, which is cool. In TeamCity, some general features. We do have a lot of additional features you can enable on a build pipeline. For instance, we have like a build approval feature. So if you want to gate part of your build pipeline, maybe the deployment stage, you can add approval rules for particular users. So I could say that Matt needs to approve this job before it's executed, which is quite useful. We also have a build cache feature. So if you need to be able to cache some dependencies between builds, perhaps you're using single-use build machines, this can help you cache dependencies between the different executions. We also have full support for notifications. If you're working with, or if you're using Slack, for instance, you can send Slack notifications to a channel. So as the build pipeline is being executed, you can trigger notifications to a particular channel or a particular user. If you're executing lots of tests, we do also support parallel tests, and this helps you to split up the test workload across multiple build machines. And that shortens the overall time it takes to run the tests. We also have a performance monitor feature, and this is really useful for monitoring the performance of your build machine while the build is running. So TeamCity will actually collect the CPU usage, the memory consumption, and disk I/O while the build is running on your build machine, and show that in a graphical representation in the user interface. So really useful way to see whether your build machines are adequately resourced for your jobs. So just a couple more things. If I go to my configuration here and look at the trigger screen, you can add automatic triggers for your builds. If you want to run a build automatically every time you trigger a build, every time you make a commit, you can choose the VCS trigger. And what this will do is when you make a commit to Perforce or to Git, you can trigger an automatic build over in TeamCity. You can also set up schedule triggers. If you want to do, for example, a nightly build, then you can define a schedule trigger inside of here. If you want your build to run on a particular type of agent, there is also the agent requirements screen, so you can add specific requirements for where the build should be executed. So if you want to run the job on a high-spec machine, maybe where it has a large number of CPU cores, you could add a requirement for a particular number of CPU cores, such as 64, and that will add a requirement for a high-spec machine. So let's look at the finished build again. So we've got the finished build that I ran yesterday. We can see the commits that were included. We can see all of the changes here. On the build log tab, we can drill down and see the build log for each of the jobs. If I click on one of the jobs here, we can see the build log for that particular part of the build pipeline. So we can see we're setting up the tool chain. We can see the compile tools, and it's grouped by the different sections of, or the different steps within that particular job. If you're producing artifacts, those artifacts will show up here, and you can also view the entire build chain or build pipeline through here as well. And then finally, on the parameters tab, you can always go back and see exactly what state the build was in when this was executed. So this will show you the config parameters when the job was executed, as well as the parameters from the build machine. So you can always go back and see under what condition that build machine was in, what dependencies were installed, the versions, path variables. So if something changes between builds, it's more obvious through this UI. Okay, I think that's everything from my side. So, Matt, are you there still?
Yes, I'm still here.
Awesome. So I guess, yes, sorry, go ahead.
No, I was just going to say it's a fantastic overview of TeamCity there. I think it's a great platform and tool for working with Unreal. There's a lot of very useful features which are kind of built in to support Unreal directly.
Yeah, that's true. And as you can see, I've been using the nice dark themes. So if you prefer a dark theme, that is one of the options that we support. Yeah. And one thing to mention, if you would like to try TeamCity Cloud out yourself and configure your own Unreal project, if you go to this address, you can sign up for a free 14-day TeamCity Cloud trial, and we pre-install the Unreal Engine plugin, which means you can come in, you can create an instance, you can add an Unreal build step and connect your own self-hosted build machine and try running a Unreal build through TeamCity.
That looks cool. Thank you both. Actually, you just showed how to switch the theme in TeamCity, and Matt, that was the command to you as well while you were presenting. Our audience actually notice you're using the light theme, so maybe you could shed the light.
See, I'm team light theme. I like light theme.
Okay.
It's good. A light theme's good for presenting as well. It gives you a nice, good contrast and everything. But yes, of course, we've got a dark theme. We've got plenty of other themes which you can do. And if we can bring up my screen a second, if I switch over to me, then it's very easy to actually change that as well. If I use my keyboard shortcut again for actions, and yep, if I just type quick there, I've got quick switch scheme, which is easier to type than it is to say. And that kind of gives me then a bunch of different options. I can change the theme itself, I can change the editor color scheme as well, key map and so on. Theme is a good one there. If I just highlight that, then I can quickly change to dark or light. I can swap between them. We've got sort of different options there as well. So you can do that. So, if you want to use like a Visual Assist style or Visual Studio coloring that you're familiar with, then you can use that. What I like to do, though, even a bit more than that, if you go into settings, the appearance, what we've got in there is there is an option to sync with the operating system, and that's really nice. I've got the my operating system set up so that it's light theme during the day, and then in the evening, at sunset, it automatically switches over to dark theme. And Ryder can do the same. It can sync with the operating system. So if my operating system is in dark mode, then the Ryder itself will be in dark theme as well. So you kind of got a nice bit of options there. In fact, with that, you can then decide what particular theme you want it to be for dark or for light as well. So that's nice. But this kind of quick switch scheme is quite useful as well, because you can change the editor color scheme. And so you can actually change it to be, well, let's go, you can go crazy if you want to and put in a dark theme. Oh, no, I did that wrong. You can go crazy and have a light color scheme with a dark theme. And so if you really, really want to upset lots of people, then you can have a dark theme for your IDE, but a light theme for your actual editor as well. That's actually upsetting me. I've got to change that back. That's just not right. There we go.
That looks good. That looks really cool. And syncing with the iOS settings means that you will definitely know that the day is over in your editor. You'll never miss that, right?
Yeah, exactly. When it's dark theme, it's time to go home.
Yeah, looks cool. Yeah, also there was another question, and kind of Daniel mentioned that there is a support for Perforce in TeamCity, and he was like showcasing this, the Perforce integration. What about Ryder? So you were using Git, I suppose, and there was a question if there is like a Perforce integration, Perforce div. So maybe you can say a few words about that.
Yeah, absolutely. So Ryder has great support for Perforce, and it will just work nicely there as well. So we can we can use the same sort of features that you'd expect from version control with Perforce. So we can see the current change list. You can edit change lists. You can move files around and so on, and also view diffs as well. As you'd expect. Pull data from the server and so on. You can work in offline mode and can automatically switch it to that between the two there as well. So yeah, great support for Perforce. And yeah, we're always sort of looking to see what we can do to improve things and make life better for people using Perforce there as well. Unfortunately, I couldn't demo that today. I don't have I was going to use a Perforce demo, but unfortunately, the version of the project that we're working on doesn't work with the modern version of Xcode, which the Mac is using. So thanks to version mismatches, I had to use a version in Git. But I would have liked to have been able to show Perforce. Maybe next time.
Yeah, and I guess quite many users of Ryder, because many of them are working in game dev, and for sure many of them are using Perforce, which is one of the most popular version control, especially like in AAA and big studios for many reasons. There are reasons for that. So yeah, and I guess there are lots of improvements coming every release to the Perforce integration.
Yeah.
Yeah, thank you. And also talking about like the TeamCity, we actually had a nice demo yesterday with the TeamCity and like Unity integration, and we had a very fantastic and inspiring Kotlin coding session for about an hour, looking at how you can do all this magic in Kotlin. And I wanted to ask Daniel, so like Kotlin might be maybe not a very familiar language to some of the game developers. Are there any other options or coming options for doing the same job?
Yeah, good question. So yeah, Kotlin isn't necessarily the first language you think of as a kind of configuration as code option for CI/CD. I would say it's very capable because it's a full programming language, so you can add lots of complex logic inside of your config as code file. Like you could have like a for loop and dynamically create lots of different jobs as you iterate over them. We do have some learning resources, so we have the full documentation for Kotlin, and inside of your IDE, you can also get full code completion if you're using like the JetBrains IDEs. We are looking at other options though. So one of the initiatives we have on the TeamCity team is something called TeamCity Pipelines, which is a reimagining of the TeamCity user experience. And in that kind of lightweight CI tool, we are actually supporting YAML. So YAML is one of the options we're supporting in pipelines. So it doesn't necessarily apply to the demo I showed today, but in the future, YAML might be more sort of commonplace inside of TeamCity.
Yeah, cool. Thank you. It's always good to have like some kind of variety. Well, personally, I think we're from JetBrains side would definitely vote for Kotlin, but other options are so cool. Yeah, and so like if you missed yesterday, so for all the audience, it was a great demo and like great coding demo, and you could learn a lot about how you can configure that for Unity if you're from the Unity side. I'm talking about the engines maybe and like TeamCity integrations. Do you have any plans for any other engines maybe and any specific support to extend it beyond like Unity and Unreal Engine?
Yeah, so Unity and Unreal are kind of first-class citizens at the moment. We have done demos previously of Godot, but that's just using sort of basic command line build steps and running them inside of a Docker container with the Godot engine pre-installed. That might be something we release in the future, so maybe a Godot-specific build step, but for now it is possible to build Godot projects using TeamCity, and we are planning to release a blog post on how that can be done soon. Yeah.
Oh, sounds cool. I'm going to read that. I think we'll have more Godot for the day-to-day, so there will be people talking more about the Godot, and there is some like Godot boost in Ryder as well. We just recently released the our own support for Godot script in Ryder 24.2. I guess that was the version. Yeah. Okay. Cool. So I don't know, Matt, Daniel, do you have any other things you would like to highlight still in regards to this topic?
Well, I think just to build on what you were saying there with the Godot support. I mean, if anybody's using Godot, please try out the latest version of Ryder. There is some great support in there. We've added support in for GD script, but not just for the code completion, syntax highlighting, and all that kind of stuff. We've also got support for debugging it as well, and that's really quite nifty. So you can connect to your game and you can debug. You can obviously step through and work through your code with Ryder. And it's been very interesting watching that happen because there's been some limitations to the debugging protocol that we're using, in that it doesn't always show you full information there, and there have been therefore updates to Godot itself to be able to support that. So as Godot itself is changing there, we're going to get more capabilities in Ryder for debugging as well. So it's a very nice sort of nice to see that happening from the Godot side of things. It's fantastic to get that kind of support.
Yeah, I agree. And it seems that all our tools become more engine agnostic, which is good.
Yeah, having Ryder being able to support all the engines it is great. It's a very useful thing.
Yeah. Okay, so I think that maybe we could thank Daniel for his part of the presentation and then continue with you, Matt, and introduce our next speaker.
Awesome. Thanks so much.
Yeah, thanks,
thank
Daniel.
you, Daniel.